Hello, good morning, and welcome to this first webinar on kineo, intelligent load. We are here today with my colleague Mauro.
Hi.
I'm Francesco, and our specialist Lorenzo. Lorenzo is, of course, work with GLOBUS, is a specialist on kineo, and he will introduce today with this first webinar the basics of the use of kineo. And then, of course, next week we will have another appointment, and these are just the first two appointments of these webinars on this machine. I think now we are just waiting for some more people to join our webinar. We are waiting around 200 people today, so just another couple of minutes, please, of your patience, and then we will start. I don't know if Mark wants to write.
I would like to take the opportunity to present Mr. Fausto Simonetta, that is going to be our specialist today. He has a huge experience with this machine, and he's probably one of the person in Europe that is very well knows of this machine. So welcome, Fausto.
Thanks a lot. Good morning, everybody.
And as Francesco said, we will start in 2 minutes and we will be back. See you soon.
Thank you. So I think we can start. And first of all, welcome everybody, and thank you for joining us for today, for this morning. I would like today to give this presentation on the kineo training methods, and we will talk about different things, different teams, and we will have Fausto, as already Mauro explained, as our colleague, because at the end of the day, we share the same passion, we share the same job as strength and conditioning coaches, and so and as trainers, as rehab coaches. So at the end of the day, this will be a sharing moment of knowledge between us, between me, Fausto, and you guys from home, and you can have live questions, so you should have a chat where you should be able to write down your questions, and then our guys behind the computer will give them to us. I don't know if we will have time for all the questions, but don't worry, because this live webinar will be recorded, and then we of course follow up your questions with all the answers. So moving on, a little presentation of what are the speakers today. As I said, me as a strength and conditioning basketball coach, a kineo master trainer, and Fausto Simonetta, who has a master degree in sports science. He's a manual therapist and both former strength and conditioning coach of the Lugano female soccer club. And as well, if you want to connect with Fausto, please share with us your interest, and then we will make contact with him. And Fausto, if you are hearing, show me Fausto, please, so I can see his face.
No.
All right, so Fausto, now I can see you, and please be free to interact, to interrupt me, and to. So I think we can start, and we will start by seeing what is the webinar content of today: the Biphasic load method of concentric and eccentric differentiated training, closed kinetic chain exercises with the elastic method, and treatment of painful pathologies with the smart viscous method, as well as muscle injury prevention with the VLC variable load curve. So we know that this will be a general presentation, so we can't, for time reason, we don't want this to be 3 hours long. We want to keep it very tight and very concise. And so we will have a general presentation of each point, because stay tuned on the next coming soon monothematic live webinars. So we will go more in detail in each of these points, in future webinars. So please follow GLOBUS, follow kineo, kineosystem.com, globuscorporation.com, and you will definitely see the upcoming live video. So as I said, a lot of things, and we will have a general point. We will use some videos. We will have some practice for each one of these points, and so we will keep it very simple, but as well very pragmatic, because if we don't want to give just the theory, our job is to put theory into practice. Okay, so starting with this, also I want to remind you that next week the next appointment is the 29th of April with Dr. Giannicola Bisciotti, who is the official advisor of performance and rehabilitation of Paris Saint-Germain Football Club, and we will talk with him, and we will have the honor to have him talking about muscular evaluation, and he has 20, 30, 40 maybe years of experience in top level clubs like Internazionale Milano, and so we will have the pleasure to talk with him about evaluation. So today only training methodologies, next week evaluation. So please also take the chance to listen to our guest Bisciotti next week. So we start. All right, we have it. We start with a little video. So in this video, there is the first point, the biphasic load, and a lot of information will be in it. So there will be a test. You will see some data and regarding concentric and eccentric loading. And maybe for some of you, it will be very easy, and some of you will be a new thing. So let's just check the video, and then we will start talking about it. Let me see if I can start the video, but it may be mine.
Always been used to setting our trainings by determining the workload according to the concentric maximal strength. However, this method does not take account of the fact that the maximal eccentric strength is much higher than the concentric one. Let's check this out right away with the kineo ratio test. This isokinetic test allows us to analyze the maximum strength in the two phases. Let's set a 0.10 meters per second speed and ask the subject to make a repetition by pushing as much as possible in the concentric phase and trying to resist as much as possible in the eccentric phase. From the test report, we can see that the subject developed 180 kilograms in the concentric phase and 320 kilograms in the eccentric phase with a 1.77 ratio. If we decide to set the workload to 80% of the concentric maximum, we'll set 144 kilograms. The load is 50% lower than the eccentric strength. That means that the subject in the eccentric phase is training with a load that is definitely not suitable for the target.
All right, so a quick video, a lot of concept with it. As I said, a test that measures concentric and eccentric, because we know how much evaluation is important in our job to fix our goals at the end of the day. And as you saw also in this video, we talk about concentric and eccentric with two different loads. So not the same kind of load like in traditional weightlifting, but different loads, of course, with the use of kineo and the machine that you can see, that you will see in this room. So starting from a step back, we of course need to make sure to be on the same page of what we say. So we know human movement has two phases, and the concentric one is when the muscle is shortening, and the eccentric one is when the muscle is lengthening. And we know a lot of things nowadays since the research has done a lot of moving step forward in the knowledge of how eccentric training works. And as well as we know there are two different phases, but we know also, and each one of you knows some of the activities that you usually do in concentric and eccentric, like running uphill is definitely a concentric dominant pattern, and running downhill is definitely an eccentric dominant movement. So those activities are definitely something that you can experience every day, and maybe you know it, maybe you don't, but we definitely understand that there are also mixed compositions, like we are not only using concentric and we are not only using eccentric. And so the importance of eccentric training, so the next questions we must ask to ourselves is, why should we have concentric eccentric differentiated loads? And for this first answer, I would like to recall one of the principles, one of the training principles, which is decelerate before accelerate. So make your athletes learn how to brake before make him learn how to be fast, how to be powerful, how to accelerate. And for this reason, and this has so many applications in the way that in sports performance we must use deceleration in many sports. Like in these pictures, you see a basketball player, James Harden, whose famous step back is definitely a deceleration movement. So in this way, making sure that deceleration is one of the capability that the athlete can do properly is not only for performance but also for rehabilitation is one of the process. So make some eccentric training during rehabilitation and of course injury prevention as well. But continuing asking why concentric eccentric differentiated loads, we can definitely say that from a scientific point of view, we understand that we understood since the 90s basically, where the first model, and let me see if I can point out on the monitor. In the first model, the spring model of eccentric training, there was two very basic explanation. Eccentric loading and eccentric training and eccentric contraction was used to either dissipate energy in deceleration or to accumulate energy and storage energy for the next concentric movement. This was, again, a very basic principles, maybe too easy, maybe not complete to properly explain how eccentric works. But this was the first time we saw this type of explanation. And as well, then we knew about strength, about stretch and shortening cycle, and what kind of role eccentric will have in movement and in performance. Next, of course, and this as well is a very old, the force-velocity relationship by Hill, and then modified in this picture by Herzog in 2009. We know definitely from this relationship that there is a shortening of the muscle where the force and the velocity have this kind of tendency and relation. So we know, for example, that at very slow concentric speed, we have very high maximal force production. As well as we know that we have a maximal isometric strength point, which is higher than our concentric. But we definitely know also, and we definitely knew what happened when the muscle was lengthening. And so we had this part of the graph where we know there is an eccentric contraction, an eccentric behavior. So this was already something that we knew by a lot of time, and we knew about the importance of having eccentric and the importance of having the an eccentric which is a higher potential force productive than concentric. So we take for granted that eccentric strength is much higher than concentric strength. But then we will ask ourselves during this presentation if we are doing enough to properly stimulate those eccentric, because we will see how we are doing it today and how we can do it with as well with the kineo, with this technology. Moving on, of course, I didn't want to bother you with the scientific, with the too much scientific side of this presentation, but you go to Google Scholar, you go to PubMed, you go to ResearchGate, and you can find nowadays a lot of scientific articles that prove either the mechanism of eccentric contraction, the role of the tightening, for example, and the chronic adaptations to eccentric training. And I will repeat myself, but we will take those arguments, so some of these, it will be part of the topics that we will have in a proper live webinar only for eccentric training. So next thing, exactly as I was saying before, is what we are doing today for eccentric. So what is the thing that we are using nowadays for eccentric? And some of the thing, I don't want to be part of it, part on one side and saying that those are not suitable methods to try to work in eccentric. We will try to only make an analysis of what are different training methodologies. So those are definitely some of the practice that you probably already know. So working with traditional weights in some exercises like a single leg deadlift, like using sliders, like in this picture for hamstring eccentric training, or the I would say world famous Nordic hamstring exercise, as well as using pulleys, as using 2 feet up and 1 down for calf raises. And the thing is, with those training methodology, we must ask ourselves if this is enough. Is this enough for making sure that that eccentric capability is stimulated in the right way, in the proper way, based on the fact that we know from science that eccentric strength is very much higher than concentric one. So the questions that I would like to ask to you guys that you are listening to these presentations is: are those training methodologies giving eccentric proper overload? Mauro, please show the screen. Thank you. Are those eccentric proper overloading from a scientific point of view in the way that we understand that eccentric is almost 1.5, 1.8 times higher than concentric strength? Is this, there are possibility of load progressions in these training methods? And as well, is there a specificity in the way that we are proposing those training methods during our workout sessions? Is there any data quantification? So are we making sure that we are not planning our workout just on our thought, but we are working with data analysis? And what about safety? In the way that if we don't, of course, this is all related. If we are not doing workouts based on data, how can we make sure that this is a safe way to do eccentric exercises? And of course, as I said, I don't want to make this those exercises are not good and kineo is good. It's not this. It's just a matter of understanding what we are doing with those and what we are doing and what we can do with this. So, for example, if we take one other thing regarding this, if we take the exercise, the calf raises, where we ask our athlete to go up in concentric with 2 legs and going down with eccentric with 1 leg, I want to make these questions to you. Are we changing the internal load of that calf, of that gastrocnemius, or are we changing the external load of that gastrocnemius? And if you ask yourself these questions, you will realize that, yes, of course, we are doing more eccentric on the leg that is taking the load of both, but as well, we're not giving any kind of proper eccentric overloading, for example. Whether if we take as an example the sliding exercise for hamstring, is there any specificity in the way that the athlete is positioned during the exercise? And so as well, we must keep ourselves conscious of what we are making them do. We must keep all the knowledge, all the information to then make the best proposition for them. All right. So in order to have some more scientific base, we collaborated also with Liverpool University, and we will now talk a little bit about this. This is a pilot study that we recently received, and in a 6 weeks eccentric loading, there were 2 sessions per week in which the group control was doing a squat with eccentric overload, and the first 2 sessions were starting with the 70% of concentric load regarding to the 1 RM concentric, and 120% eccentric load. And in the next section, in the next weeks, they purposely increased that type of numbers in the way that at the end of the 6 weeks, those 2 numbers were definitely higher, and the percentage, the ratio was definitely higher. As well, the results was that doing eccentric loading and eccentric training with this proper, let me say proper eccentric training with differentiated loads, there was an eccentric strength increase as well as a concentric strength increase, and a counter movement jump increase in the way that they also made the testing. And one cool thing was also that they get the transfer between 1 RM concentric increase in the traditional barbell. So making sure that the evaluation with the kineo was also transferable to the evaluation on the traditional barbell. And I don't want to be so long, but the no DOMS effect, we always heard talking about eccentric as sometimes a dangerous way to train, because we are afraid of DOMS, a delayed onset of muscle soreness. And by the fact, there are 2 points to keep in mind. If you train eccentric, you will have what is called repeated bout effect. And the repeated bout effect is basically the effect of eccentric loading made in a constant way each week for a lot of time. It's making sure that there is an adaptation. There is that kind of adaptation that doesn't involve any more DOMS into this practice. So it's not true anymore that eccentric training, if done properly, if done with data quantification, with objective loads, and not just 2 legs up and 1 down, is definitely a safe way to do eccentric. And that's, I will say, let's practice and let's make some examples of the biphasic load, and as I will say also the real eccentric load. So I will ask Damiano now, is our athlete for today. We will move to the pulley squat workstation. So let's wait for, okay, we're good, perfectly. All right. So basically here, what will you see? Yeah, you will see different type of models here. Here there is the pulley squat, which is made by the squat platform, the pulley, and this is an accessory for the lat machine exercises and all the exercises, the cable exercise for an upper position. And here you see the leg press, which we'll try later. Then Damiano, please. So with Damiano, we will make a biphasic load exercise in this way. We will find isotonic needs, as you see here. Kineo has different training methods. Today we will only see some of them. And of course, there is also a test section that we will see next week. So by the training methods, we select isotonic needs. The exercise will be a biceps curl in the squat platform, just to make an example on how easy it is to manage loading in concentric and eccentric. Those are kilograms, exactly how we measure everything in traditional weightlifting. So, for example, we take 10 kilograms in concentric and we put 20 kilograms in eccentric. This, as you see here, there is concentric feedback or eccentric feedback. Now, this basically will transfer on the display what is the execution of Damiano, and we will see how he is properly doing eccentric training. Okay, so we click next, and please, Damiano, come here, take the bar, and we will start. Of course, right now you can see the screen. Okay, let's turn it on. Sorry. All right. This is better. Yeah. Okay. So start. You should see the screen also on your laptop. And please go, Damiano. What you see during the execution is the biofeedback in eccentric. So right now, Damiano is doing 0.6 meter per second, 0.28, 0.37, and so on. So right now, Kineo is not only giving you the exercise, it's giving you also the analysis on how Damiano is performing eccentric. So now, let's make also one quick example. Now, there is a trend. So please stop, thank you. We can see a trend here. So we see that Damiano was training almost at 0.32 meter per second. But as you can see, the biofeedback set his target line, the green line, the execution line, too high. It was the first repetition. This is an automatic mode. Whether we can also select a target for him. So what we can do is making manual biofeedback and taking the speed for the next series at 0.2 meter per second. Now, as you can see, the green line is set as 0.2, which means that now Damiano, please, will make sure to follow the instructions of Kineo to set each execution on the green line. Go. Yo, the first one is free. All right, now you have it. Perfect. 0.32, too fast, too fast. Slow down in eccentric. All right, better. slow down in eccentric. Of course, this is part of the learning curve that eccentric has with this type of training methodology. It's not for everyone to just keep 10 kilograms, 20 kilograms in a very correct way, like, yeah, there we go. A green one, we have it, 0.21, very good. Take a look also at the screen, Damiano, don't worry. Just to slow it down, perfect, that's good. All right, perfect, thank you. And as we understood how this is so easy, we can then practice, for example, a squat exercise. So please, Damiano, follow, take the jacket. Change the workstation from pulley to squat, as you can see here. So now the machine can understand what type of exercises we are doing. And yes, please. As you see, we use a jacket to do the squat exercise. We don't have something on our shoulders. The weight is not on our shoulders, but it's on our hips. So we must concentrate on the work of the lower limbs, and there is a proper back support also here. So like before, we can do easily 30 kilograms in concentric going up, and let's say 40 kilograms, 45 kilograms in eccentric here as well. Next, and start. Please, Damiano. Center. Okay, so please go. All right, keep your, all right, good, thank you. And those are just examples. So you can manage the load, and in the webinar that we will do on eccentric training methodology, we will definitely go into the detail on how to manage concentric and eccentric loading in the proper way. This is just an example, so don't take by granted that 30 and 45 kilograms are the ratio, because either Damiano is already trained with the kineo, and as well, different people and different person have different capacity. Okay. So thank you. You can take off. And as well, kineo goes. I don't want to go into the details too much, but here you can see all the analysis of each training. You can have the average and the peak of the strength, the power of concentric and eccentric, and then you get a ton of data. I will go very fast. You will see load curves, you will see fast speed power curves, and as well as all the numbers that you may want, in the way that this is not only a machine for training, but is also a machine for research, a machine for data quantification and specificity.
Lorenzo, there is a questions regarding the loads that you can have, you can use on the kineo. What are the different loads you can use on the squat?
On the squat,
yes.
Okay. So yeah, basically the machine is capable of doing in the squat up to 400 kilograms. And the pulley cable, so which is mainly used for upper body, is up to 110 kilograms. As well, we will see the leg press here is also up to 400 kilograms, and the multi-station, so the leg extension, the leg curl, which are more of isolation work, is up to 110 kilograms. It's okay, Francesco?
Yes, thank you.
Thank you. So we move on now. Thank you, Damiano. I will disturb you later. I don't know, Fausto, if you're still here, if you want to add something to what we have done.
Yeah, Lorenzo, and I want to speak about, a little talk about my own experience with this kind of method. And when I began a kineo user, I discovered many options. Many options are so very, very important. But I realized that the big one was the biphasic load.
Fausto, interrupt you. They told me that you need to switch on the camera. Perfect. Thank you.
Oh, okay. So
Thank you.
yes, and I'm just talking about my own experience, okay? And when I began Kineo with Kineo user, when I use Kineo, I discovered so many options, and the big one for me was the biphasic load, and there are several very important scientific studies that show how is important the eccentric training. And we did rehab and headlights and stuff like this. And for me, it represents one of the most useful weapons into the rehab field for me. But you know, my difficulty was how can set the proper training load in this situation with Kineo. I can just tapping the screen to describe to setting the concentric and eccentric load. And that's the only one. That's the only one thing. But there are a lot of other things that I can say about, you know, this kind of method. Okay, we have you can follow. I think that this with this situation, in this situation, you can follow the physiological nature of muscle contraction because you can subdivide the two different way of charge for the load. Sorry. And recreate what is exactly a real eccentric training. I don't want to say that the other kind of training are wrong or something like this. Absolutely,
yeah, of course.
But
of course,
I want to say that this Kineo can let me explore every single session, every single exercise, every single set. For me, it's absolutely important.
Yeah. Thank you, Fausto, for your experience. Of course, now we move on to the next chapter, which is the elastic, and the elastic done in the closed kinetic chain patterns. So I want to keep it as well very tight. So in this, as I was thinking about how to introduce elastic, I was thinking about this. So a squat exercise, a closed kinetic chain exercise, where you have different angles, different working angles of your hips, of your knees, of your ankles, and as well as everybody has experienced this. When you are in the first position here, your muscle effort to go out of this from this position is very high. Whether as much as we go up into the movement, the muscle effort is definitely lower, and this is not because we are not loading, but this is because of the biomechanical structure that we have. So we have different angles working from hips, from knees, and as well as we move up. And we open up the angles, of course, we have more possibility to have more strength. So it's not, we don't have the same strength when we are, for example, in this position or in this position. In this way, I have very much more potential. When I'm very low, I don't have the same kind of strength. I need to make more effort to come out from this position. So we understand that our human body works in this way. We have different angles that have different potential of force production. And talking about elastic and talking about exactly the force production capacity, if you imagine now that those orange rectangles are our elastics, our therabands, our elastic bands, as well as we go up in the movement, we have more and more tension. So the elastic in this way is following our biomechanics, as well as when we are lowering down, we don't have a lot of strength. We don't have. We need to make a lot of effort to go up, and as well as we are moving up, we definitely have more potential of the force production. So we have with the elastic, we have more possibility to have higher load in a high position. And as well, let's take what we are doing today. Why do we use elastic resistances? So nowadays we see a lot of exercises also with elastic, with weights and all kind of exercises. And we definitely use elastic bands for variable resistance because it is the first way in which we can have a variability in our movement, in our exercise. We definitely use elastic for shifting the point of muscular tension at the end of the range of movement, which traditional weightlifting cannot properly do. If we do a squat, when we are coming up and we are in a basic extended position at the end of the squat, of course our muscle tension is not at the top. And what if I go back to this, what we can at the end of the day have is that in those angles we are not properly overloading those angles. Those angles can produce much more force, but as well we use elastic to have a muscular tension at the end of the range of motion. We use elastic bands also to replicate some sport-specific movements, because there is this in the use of these things, the elastic bands, it's really easy to replicate some of the movements. For example, a throwing, for example, exercises for core stability, and so on, which gives, of course, variability in the way that the elastic is not a fixed load, but also can replicate some positions, some posture that are sport specific. And I want to give, let's say, a little bit also. I shared with Fausto this thought yesterday, and I want to give this question. So I always hear talking about elastic resistances that they introduce eccentric loading, and I will say let's stop for a minute, because yes, it's technically true, because whether you pull out an elastic, if you pull out an elastic, of course you will have the same kind of tension when you go back. And when you use the elastic for this purpose, of course you are giving some variability in the way that you move, also in eccentric. But let's keep in mind that this is with the same tension. So we are not following our concentric and eccentric different strength production. Okay, so let's stop for a minute and we will see then how elastic can be implemented in a different way. So next is another video, another quick video on how elastic method works. It will be very, very short.
Imagine that we are at an advanced stage of the ACL recovery, for example, at the 4th, 5th month. We can suggest a squat exercise with elastic load of 30 kilograms at 90 degrees, reaching 60 kilograms at the maximum extension. Imagine that we are at an advanced stage of the ACL.
So as we understood by the video, we can set 30 kilograms, and this is very clear as well. We can set different objective loads and create different elastics. So in the way that an elastic is a linear progression of the load, we can set two different elastics, and here we are seeing in the software what is a concentric elastic and an eccentric elastic in differentiated load. So I will say now we can move Damiano as well with the practice. So Mauro, please, we go to the leg press now. And yeah, let's just check. Let's practice. And so we try the leg press now with the elastic method, as we saw also in the video. For those of you who don't know how this machine works, basically the kilograms are done inside the machine by an electric motor, and there is of course a software and many sensors that control each parameter of the work. Okay, so Damiano already knows our leg press, so perfect. Please take your feet up. We can see, yes, we can see the screen quite a bit. Okay, so we go back, our training methods, we select elastic, and as you can see here, we go from concentric first position and eccentric end of the movement of the concentric. So those two loads are the first elastic, the concentric elastic, and those two are the eccentric elastic. Okay, so just for start, we select 60 kilogram. Of course, Damiano is a very strong runner, has very strong legs, so I'm not afraid to put some load on it. And we click next. So right now, Damiano is starting from this position at 10 kilograms, and whether he moves, at the end of the movement, there will be 60 kilograms in a linear elastic way. Like imagine here, there is an elastic attached to our leg. Please go. All right. Do not hyperextend. Perfect. Good. As well here, of course, right now it's just for camera purpose. Damiano cannot see the screen because it's tilted. But of course, here we have the same biofeedback for Damiano to follow his execution. Now everything is perfect. And all right, good. So this was just brief, a very quick example on how easy it is to make an elastic with objective loads. We select the first load, 10 kilograms, and we select the end of the load, the end of the range of motion. But of course, here the possibilities are very different. Like, for example, we could have something like this. And here you will recollect the fact that we can do differentiated loading also with elastic. So this is a proper way to have eccentric loading with elastic. He will have 10 to 60 kilograms in concentric, but he will have 90 kilograms from here, and he will go back in eccentric with more load at the end of the range of motion. So let's try it. And keep in mind this, the problem of overloading in elastic doesn't really exist. So please, Damiano, go. Because we must understand that, of course, in the open angles, so when Damiano in the position of open angles has definitely more strength, he's capable of doing more. So we are definitely not afraid of putting him with the 90 kilograms, which maybe for a different type of patients could be high, but in this case for Damiano is completely okay. All right. And of course, this again is just an example. We could do an elastic with a patient treating ACL, treating tendinopathies, treating Achilles tendinopathies, doing calf here on the leg press. We could do many things. And we can do elastic from 10 kilograms to 15 kilograms. So a very low load even for the leg press. And of course, here, one thing that we can do is to avoid having an elastic. So in this case, we are programming an elastic just in concentric and then going back with the same load. So let's imagine that Damiano is a patient, has a surgery, and he needs to start working early. So we must be in control of these tissues, in control of his pain, and with elastic, we can help him trying to rebuild his capacity of work. Okay, one other thing that I wanted to show you, because it's really the elastic method is really one of the best one to do it, is the jumps, the plyometrics in the leg press. So what we can do here is select like 10 kilograms as well as before to 50, and going back 50 to 10. And this will be an elastic, and I will ask Damiano now to jump. Okay, so fai 2 salti, anche okay. So now I said to Damiano to jump with 2 legs. Of course, we can do monopodalic exercises. All right, very good. All right, perfect. So of course we can do 1 leg, we can do both legs going up and down. But I wanted to show you another quick thing that I think is a more of a plyometric work in the way that we do more eccentric and then we push in the concentric in a powerful way. So I will make 10 to 40 kilograms eccentric and then 60 kilograms going back. So what is going on here is that Damiano will have definitely more load in eccentric, and then you will have low loads in concentric. So don't worry about the resisting, but we use this to give you overloading in eccentric to storage energy and then to go up in a powerful way in the jump. Okay, more of a plyometric. Quindi tu non resistere e fatti tirare indietro e dopo fai un salto, quindi tu avrai più carico in fase eccentrica quando torni indietro. Ok? So, io salto subito il primo. No, prima farò normale, ok, così capisci. Bene. Adesso salta. All right. Good. Continuati. Vai. Okay, so if we ask to Damiano to do more about plyometrics, so we build up more of eccentric loading, and then he can use that storage force to do powerful jumps in the concentric. Thank you, Damiano. Okay. All right. All right. So I think okay. We are running with the time. We want to keep it tight. We have still two subject to matter. I would like to say that those again just as examples that you can do in either exercises, in the pulley, in the leg extensions, doing eccentric work for hamstring exercises, doing those systems are very versatile. So you have plenty of accessories. And so those are just examples, okay? So Mauro, please, we go back to the presentation, because now we have one of the major concepts, one of the most innovative methods, which is the smart viscous method. And an image to give to explain smart viscous is training and moving into a fluid. So what we usually do into a fluid, we manage the execution and we have complete control on how much resistance we want to have. If we move fast, we have more load. If we move slow, we have definitely less load. So those are just examples of movements that can be replicated then with our systems. And the smart viscous method of kineo is if we have to make a definition, is then a methodology that can replicate what is the behavior of the resistance, the load, into a fluid. So when I was preparing this, I tried to condensate and make a simple one definition of the viscous load. The viscous load is an adaptive load that changes in real time depending on the execution of the subject. the applied load is then related to the increase or decrease of the speed, as much as we do into a swimming pool. And it makes the force profile completely free to change. So we don't have a fixed load, but we have a variable load. And in this method, kineo has 6 levels of viscosity. Mauro, if you want to switch it, zoom it out. We have 6 levels of viscosity. So try now to imagine to not move, do one movement. If we do a pull, one movement, sorry, a push movement into the swimming pool full of water, what it could be to have that movement into a more thick fluid, like a swimming pool full of honey, full of oil. So more thick fluid that gives more resistance to our movement. And then if I move fast, I will have more resistance. If I move slow, of course, the density of the fluid will not give me much load. In order to also explain this from a more technical point of view, what are the concentric viscosity and how they work? Basically, we start the movement, the exercise, with an initial load. Okay, so we have, for example, 10 kilograms as our initial load, and try to imagine this initial load as, for example, the surface of your hand when you are swimming. So when you're swimming, you have your surface of your hand, but if you put something on your hand to make it bigger, of course you will have more initial load while you're doing the movement. So if I use Visco 1, what happens is this. Basically, Visco 1 gives us some kind of range of variability. In here, you will see our speed that can increase or decrease, but of course, Visco 1 has a certain level of viscosity. So our range of variability stays on that. If we use Visco 2, of course, the same type of increase done in a different fluid makes the load goes up, and of course by the change of the speed. Visco 3 as well, much higher viscosity. If we do the same type of increase of the speed, we will have more and more load, and so on. So if I use Visco 4, it will be more load. If I use Visco 5 and Visco 6. So you can understand now that with the same 10 kilograms, I could probably reach very high loads here, or I could reach not much than 12 kilograms, maybe 13 kilograms, 14 kilograms. And this is depending on my execution. So each viscosity level is a load variability range of increase, because we are talking now in concentric. So concentric, if I speed up my movement, if my speed of the movement goes up, my load goes up. Okay, pretty clear, pretty tight to understand. Then, if we see of what is eccentric behavior during viscosity, of course, is the same, but done in the opposite way. So now you can see that our final load is 80 kilograms, because we ended up, for example, the movement of squatting. So we are in an upper position, in an extended position, and we have 80 kilograms of eccentric. Now here, each viscosity level has a load variability or range decrease, because try to imagine this. If you are doing an eccentric of 80 kilograms on your shoulders or with the squat, and you are not sure if you have the possibility, what's going on? Can you hear us? We are having maybe some technical issues. Fausto, can you hear us? Can you hear me?
Yeah.
Okay, can you see the video, or is it freezed?
It's full.
It's freeze for me. I can hear you, but the video is blocked. It's sort of blocked.
Okay. Okay. We are having some sounds is okay. Okay, but the video is freeze. Okay. So right now, please bear with us. This is the beauty of live webinars, and I'm sorry for this technical problem, but let's see if we can make everything run again. Our guys behind the PC. Well, in the meanwhile, if Fausto, you want to add something on what we were talking about, so maybe
yeah, sure.
we can.
Yeah,
we can.
Sure, Lorenzo. Yeah, I'll just yeah. Now all right. So, and the Viscous, let's talking about the Viscous mode.
Yeah.
For me, at the beginning was, a sort of a mysterious object. And because I thought that when I was started, I believe that the traditional method was fine and in my daily practice. But when I discovered the inner potential that the Viscous showed in several situations, and when the patients on the client's pain has stopped the set of the exercise, and the viscous load, as Lorenzo said, is deeply connected with the speed of the exercise speed that you are doing. That's right.
Yeah.
Or if you increase the speed and the kineo load becomes heavy. And if you are into the painful angle of the range of motion, you just decrease your speed, and in the machine can reduce in real time where is the training load. It's extremely useful for me. For my own opinion, this is one of the most important feature in kineo, and it's worth to be discovered for me. And I have two real cases that I have in rehabilitation business, and because it is very, very adaptable and a remarkable number of clients and patients. And I reached very good results with the Viscous training. In a shoulder rehab, for example, with the whole lady that she has not been able to perform an external rotation of the shoulder, and I use the Viscous mode to let the patients to choose exactly what is her load.
Yes, because
the real thing. It's very, very important thing, because you have the chance to let him change, choose. Sorry, the load, and
exactly,
you just increase or decrease the speed. And
yes, because exactly the patient. The patient in this way is able to completely control what is his execution. So, for example, if we have an athlete, he is coming out from a surgery, from an injury, and we must, as strength coaches, as rehab coaches, work with the physiotherapist in order to make him play again. We need to start with the load progression, and we must manage pain as well. So the Viscous mode lets the patient, your athlete, to manage what is his workload capability, because week by week his workload capability must go up, and it must go from a very safe condition to a more of a performing condition for the return to play. Fausto, I see one of the questions that our guys from home are writing to us, and I want to have your opinion, since we are still having some technical issues with the webcams, and I'm sorry for that, but let's keep this time to continue to share some of the thoughts. And we have Lorenzo from Portugal, which is telling us, how do we know what level of viscosity we should use with an injured patient? So give us if you want, I can start with my answer, and then you can follow up with your opinion. Okay. Yeah. So Lorenzo, for the level of viscosity with the patient, of course, we must take care and we must consider what type of patient, what kind of injury. But let's consider this, like as we were saying before during the presentation. If you use low viscosity in concentric, you will have less load variability, and the result of the movement will be a little faster movements and a more smoother execution. Of course, if you use Viscous 6, you will have definitely a higher load, definitely more difficult execution. So I will suggest you then to select and try to select a very low initial load, as well as you understand that the patient is capable of doing, for example, 5 kilograms, and then starting to work with Visco 1 with a lower viscosity and see how is it performing. Because always remember that Viscous in this matter, it's also a way of testing our athlete. You know, nowadays we always hear about testing our athlete each training session that we have with them. So of course we do evaluation at the beginning of the season, for example, and at the end of the season. But each training workout for us is a way of testing how he's moving, how he's doing the. Oh, there we go. We're live. Oh, perfect. I was now thinking that we didn't have our webcam back. So yeah, so starting from definitely lower viscosity is the way to start treating with the patient, in my opinion. Do you agree, Fausto?
Yeah, absolutely. And the real important thing is to consider in the Viscous method, you have two choices to increase your load: viscosity and the external load. Okay. Yeah. You can manage every single session, every single set, change and modifying this section. Okay. And if you increase it with the same external load, 5 kilograms, for example, you have a chance to increase the load, increasing your fluid resistance. With fluid yeah. Number 6 is higher than the 2, the 3, and the opposite things in eccentric contraction is very, yeah. Very adaptable for me. And I have another great results that I got with a young tennis player with surgery at the knee. She lost the full extension, and nothing comes up, you know, with the traditional method. Okay, by using the Viscous training, we have great results and a letter free of pain by using the Viscous mode. And we recover yeah. The complete knee extension, and for the shoulder rehabilitation or something like this. Okay, it's very, very useful for me.
All right, thank you, Fausto. So as well as we get back to the presentation, since the webcam fortunately gave us some minutes to talk about the questions, let's go back to the display, Mauro, please. All right, so we were talking about eccentric and how does it work with viscosity. So let's try, we will see later in the practice, because it's easier to see how does it work in the machine than on monitor. So in order to give you a full disclosure of what is visco load, viscous load takes into consideration all those parameters: the range of motion, the speed of the movement, as we said, and the movement pattern that we are using, because of course this is correlated. The movement pattern is definitely correlated with the speed, the increase of the speed. So if we are doing, for example, a deadlift, we will have in the first phase of the movement a very high acceleration, and so the viscous load gives at each point of the movement the optimal load for this kind of exercise. And if we need to talk also about fatigue and pain, and in order to do that, we will see now two introductory videos, but the first one will be on fatigue, the next one will be on pain. And the basic concept is this: we don't have a fixed load, we have a variable load. So what does it mean? If the speed of your execution is going down, it means that either you can have fatigue during your execution, you can't hold up the last repetition, or you're feeling something. So you're feeling something on your articulation when you're doing the exercises, and so you have you slow down as well as you have pain. You slow down usually, and usually you stop. But we will see how then the Viscous is adapting the load each time if you increase your speed or decrease your speed. So, Mauro, let's run the videos, please.
In the data analysis, we can see that kineo has perceived the effort as repetitions, increased and adapted the repetition load in both the concentric and the eccentric phase until the end. In the data analysis, we can see that kineo has perceived the effort as repetitions, increased and adapted the repetition load in both the concentric and the eccentric phase until the end.
So, as I said, in this video, in this first video, you were seeing
of Viscous method is considered ideal for painful.
All right, sorry. The video started immediately, and the first video was about fatigue, meaning that the machine is adapting the load even to your fatigue, whether you, at the end of your set, you're doing the last 2 repetitions, the last 3 repetitions. The machine helps you like a spotter. Like in traditional weightlifting, we have someone helping us when we are doing the last repetition. Here, everything is done by this technology, and is done by automatically based on your execution. So if the last 2 repetitions you are moving slow because you are fatigued, the machine is not giving you the same load of the first 2 repetitions when you were fresh. Now the last 2 repetitions was where the machine is helping you a little bit, lowering down the load. Next video is about the pain threshold, and we will see in the analysis how the load and the speed are adjusting itself to the pain.
Apologies, because the load adapts automatically while staying always under the pain threshold.
All right, we see it again.
The smart Viscous method is considered ideal for painful pathologies because the load adapts automatically while staying always under the pain threshold.
So, as we see here, the machine is adapting the load, and is adapting the load based on your execution. So if you, as we said before, if you feel pain, you usually slow down your speed, first of all. Immediately, the machine can recollect this and lower down the load just in the point, as we see here on the screen, Mauro. Here in the monitor, you will see there is this kind of deflection. Like here, something in this part of the movement, everything was going okay. So the load and the speed was increasing. And then here something happened. So we must, of course, take this to a more of a clinical analysis with our athlete, with our patient, asking him what happened, if he felt something, and so on. But here we have the possibility to train under the pain threshold, because immediately we can set and see what is the pain, where is the pain, at what angles. So in this way, we have a smart way, as Fausto was saying before, to train without pain, to give the instruction. I always use this with my athletes. I always say, when they are recovering and they are using kineo, I say stay without pain. So let's try to build up the load, let's try to have a smooth execution, but don't feel pain. Don't put yourself in a condition to harm yourself again and to injure yourself again. And in this way, we are seeing that our job is definitely easier in some kind of way, because the machine is adapting the load automatically, and the patient is feeling definitely great to have the optimal loading at each kind of movement that we are proposing here. Some of the applications of the smart viscous load, as we sum it up, is the early loading in rehabilitation, in the way that, as we see then during the practice, we can reach very, very low loads automatically, and we can start very early with the rehabilitation, having the patient manage his pain through the execution. Then we can set, of course, a progressive optimal loading. And as I said before during our break, that Viscous is a great method also to have a training as testing, and as well as a safe eccentric loading method to start building your eccentric, because the machine, as well in concentric, in eccentric works in a different way. If you can afford 80 kilograms, the initial load of 80 kilograms of before, the machine is adapting the load of what you can resist in eccentric. Okay, so in concentric, it gives you more load if you increase your speed. In eccentric, it decreases your load if you are increasing your speed. If you increase your speed, it means you are not decelerating well. If you're not decelerating well, it means that your eccentric capability is not trained enough to have that kind of load. So let's practice. We'll have a very quick practice because we are running out of time. Damiano, please come here to the leg extension. All right. Let me change the configuration here. No. All right. So now we have the leg extension here. We have the possibility, of course, to have all the straps for the evaluation. We just keep it very, very quick now. And we go immediately to the training. We select leg extension. All right. We go to the Viscous. And now we select the first concentric one. So we start with one leg exercise. We will do just a single leg exercise extension with his left, so la sinistra. We will start with the 5 kilograms and Visco 1. In eccentric right now, we don't put any Viscous because I want just to make him do concentric work. Then we will try also the eccentric one. So we click next, and please take a look at the screen, because in the screen right now, you will not see the speed of execution, but you will see how much load. Well, I need to stay here. Okay, let me say that you will see how much kilograms, how much load the machine is giving you to Damiano, and Damiano is deciding based on his speed how much load he wants. Okay, so let's start. Damiano, the first 3 repetitions, take it very slow, slow. Molto piano. All right, very good. So right now he had 6 kilograms, 7 kilograms. And this is exactly one example of making a leg extension exercise for early rehabilitation with the very low loads. So right now, Damiano, imagine that he had some pain, he had some recovery going on, some rehabilitation going on. He is deciding how much kilograms. I'm not deciding. I'm not putting a fixed load for him on the leg extension with all the problems that leg extension exercises may have, because this can be done on leg extension, on leg curl, behind, on leg press, on everything. Okay, so next execution, we continue with the next series and try to move faster. Try to move faster, quindi un po' più veloce. So now I ask to to move faster. All right, 8, 10 kilograms. As well as his execution is faster, the machine is giving him more load. Okay, stop. We do a quick change because now I'm not putting him in Visco 1, but I'm putting him in Visco 4. So remember the graph, the higher viscosity. Now try to keep a very fast pace. All right. Now he's producing 21, 22 kilograms. He's making definitely a different kind of fatigue, of effort during this exercise. But still, if the next one now go a little slower. Now go a little slower in the next few repetitions. Clicking start. And now with the same type of viscosity, we can do the same slow execution as before, 14 kilogram, 16 kilogram, as well as before it was 22. So in this way, again, we can manage the load by his execution. I'm not giving him a fixed load that he may or may not tolerate as well, because maybe there was some tissue healing going on and some pain still in during his movement. All right, thank you, Damiano. And we are good with the leg extension. So we go on with the presentation, and we see the last point. Okay, so variable load curve. I will be very quick on this. It's the more advanced way to have a variable load curve programmation into an exercise. So you have, as you can see here, a curve with the range of motion on your x-axis and the load applied in each point. So here you can display 10 points in which we can manage the load going up and down. And we run the videos. This is basically the more advanced way to program a load curve. This is my exercise. This is my range of motion. And here I can manipulate the load as much as I want. All right, let's run the video.
To take an example, think of a leg extension exercise for a patient who has got a pain at a specific angle of the movement. After making an isokinetic evaluation and detecting the pain point, for example, at 45 degrees with the VLC method, we can decrease the load in the pain zone so that the patient can make the full movement without feeling pain.
All right, so here you saw a little bit of what are the application. Here we find the pain zone, we take down the load with a variable load. And so some of the application of the variable load are the rehab application, like painful degrees pre-exercise, and the load shift for safe retraining. For example, in some of the pathologies of the knee, like tendinopathy in the patella, you definitely can manage the load in the most critical point after a clinical testing, a clinical evaluation. Another application of the variable load, and I'm going very fast.
Another application of this work method is the use of load spikes in some points of the movement. The aim is to create a sudden stimulation that trains the subject to improve the muscle activation time. For example, in a lateral movement exercise, we could set a 10 kilograms first load and a 20 kilograms return load with 2 short 35 kilograms spikes. This exercise is excellent to stabilize the ankle, the knee, and the hip. Another application of the variable load with spikes is in hamstring injury prevention. We can add 2 short spikes during the eccentric phase and leg curl, analytical exercises, as well as in free cable functional exercises.
All right, so here we saw another application, a more of a performance application for athletes, a more advanced return to play phase where we try to replicate some of the spikes, so some of the stimulation, the perturbation that we have during the game. And so some of the performance application of this is then to try to work not only in strength, but work on the neuromuscular training. So trying to give some sudden stimulation and to have some reactivity work. And of course, then this was one of my let's say way of making me a question like, isn't this neuromuscular training and isn't this injury prevention? So having something to react, working on stability, working with variable loading, and definitely not using only one fixed load. The human body works in a very variable way, and so we must switch our mentality into using more variability into our loading. Of course, taking care of the basics, taking care of the athlete having strength before moving to power, and so on. All right, we are running out of time, unfortunately. Again, this was very, very quick as a general presentation of each point. There will follow more events like next week with Giannicola Bisciotti, as we said at the beginning. And Fausto, definitely your experience and your contribution was great for us today. And thank you again. If we will have some other questions directly to you, we will forward it to you. And Mauro, if you go out to the
yes, we can answer perhaps to one of the questions we have. We received a lot of questions today.
the camera.
And we can answer perhaps. Just move the camera on.
Okay, we can.
Yeah, we can stay here. There is a question, for example, that is, I think that is very interesting, that is talking about the advantage of the Smart Viscous. Could we use all the time and give up the isokinetic mode?
Yes, yes, definitely. The viscosity is one of the methods that can let's say not replace isokinetic. Isokinetic training has definitely his type of training, his type of execution, and a certain characteristic. Viscosity gives into account the variability of the load, the variability of the patient to change the speed. And we think, as expert of this kind of methodology, that of course taking care for me, for my basketball players, taking care into my training, into my testing, the speed variability is definitely a step forward in the methodology than considering normal isokinetic, which fix the load, fix the speed during the execution. I don't know, Fausto, if you want to give your opinion also on that.
Yeah, I agree 100%. The focus in the viscous mode on speed of motion. Okay, by that way you can collect an enormous number of data that you can put in your daily practice. It's a different things. I absolutely prefer the viscous mode, and because it testifies the extreme versatility of kineo. You can find your own way to recover and train and stuff like this.
All right. So I think it's a wrap for today.
Yes, just to remind that you can find all the videos about the training with Kineo, tutorials, and these webinars as well in the future on our kineosystem.com website. And please visit it on a regular basis because we keep updating it. And I think maybe we can also remind that next week on Wednesday, 29th of April, we will have the next webinar about muscular evaluation in rehabilitation and high performance with Professor Bisciotti, and of course with our expert Lorenzo. And that being said, I think
yeah, there will be also more courses like this on training methodology going on. Today was really quick presentation, general presentation of each step. Then we will go into more detail into eccentric training, into viscous use, into the new type of methodology that we are now seeing nowadays with this type of technology.
So thank you very much for your attention, for staying with us, for spending this time with us. We hope that was very useful for your next step into the rehabilitation and training. And if you need some information about our Kineo, you can get in touch with your distributor in the area. They will be able to give you all the information, or writing directly to us, and we will be very happy to helping you to discover more about Kineo. As my colleague says, see you next Wednesday, and have a nice day. Thank you, Fausto, for great help. As always, thank you very much, Fausto. And see you next time.
Bye-bye.
Bye now. Ciao, ciao.
Bye.
Bye.